The composition of a function and its inverse has a special property. F inverse of f of x equals x, and f of f inverse of x equals x. This is a good tool to determine whether two functions are inverses of each other. So when we have, for example, the functions f of x equals 2x minus 3 and g of x equals 1/2 x plus 3/2. We just check if these two statements, f inverse of f of x equals x and f of f inverse of x equals x, are true. The only thing we have to do is to plug in f of x and g of x, and see if we get x as a solution in both equations. So we can write f of g of x equals 2 times 1/2 x plus 3/2 minus 3. Two times 1/2 x is x, and 2 times 3/2 is 3. So we get x plus 3 minus 3. Three minus 3 cancel each other out, so we get just x. Let's check the second statement. G of f of x equals 1/2 times 2x minus 3 plus 3/2. 1/2 times 2x is x, and 1/2 times negative 3 is negative 3/2. Negative 3/2 and 3/2 cancel each other out, so we get just x. Because f of g of x equals x and g of f of x equals x, the functions are indeed inverses of each other. Let's look at the next example. F of x equals 2x minus 6 and g of x equals 1/2 times x minus 3. Let's start again with f of g of x equals 2 times 1/2 times x minus 3 minus 6. 2 times 1/2 times x is x, and 2 times negative 3 is negative 6. So we get x minus 6 minus 6. Negative 6 minus 6 is negative 12. Because f of g of x does not equal x, we can stop here. F of x and g of x are not inverses of each other. Always keep in mind that both statements have to be true. When f of x and g of x are inverses of each other. More to come, so stay tuned.